Alright, so if we want to find the sum or difference of any of our trig functions, and we're given, say, cosine of alpha is square root of 5 over 5, as long as alpha is greater than 0 and less than pi over 2. And sine of beta is equal to negative 4 over 5, as long as beta is greater than negative pi over 2 and less than 0. These conditions out here are going to tell me where the angle measure alpha and angle measure beta are located, which we will need because, as you know, the formulas for the sum or difference of sine or cosine have or need sine of alpha and cosine of alpha. They also need sine of beta and cosine of beta. We're only given one angle measure evaluated at alpha and one angle measure of beta. So what we need to do is we need to first remember the formula. So like for sine of alpha plus beta, that's going to be the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. Now we were given that cosine of alpha is square root of 5 over 5. So this right here, this can be plugged in right here. We're also given that sine of beta is negative 4 over 5. So that right there can be plugged in right there. So what does that mean? That means I need to solve for these other two. Alright, so let's see how we would do that. All we need is that one value, and using x, y, and r, we can figure out the other value, or the other trig function evaluated at that angle measure. For example, if we know that cosine of alpha is square root of 5 over 5, this tells us we're in the first quadrant. So when we find the sine, remember in the first quadrant, if we're here, y's are positive and x's are positive. So whenever we do use x, y, and r to find the sine of alpha, we need to make sure that our y is positive, right? So how would we use that? We know that the cosine of alpha equals square root of 5 over 5. Cosine is also equal to x over r. So if x is the square root of 5 and r is 5, then we can use x squared plus y squared equals r squared to solve for y, which we need for the sine of alpha. So let's plug in those values. So you have square root of 5 squared plus y squared equals 5 squared, or 5 plus y squared equals 25. Solve for y. I have y squared equals 20. Take the square root of both sides. So y equals plus or minus the square root of 20, which simplifies plus or minus square root of 4 times square root of 5, so 2 square roots of 5. Now we're in the first quadrant, so our y is positive. So our y is going to be a positive 2 square roots of 5. Alright, so I can now figure out that the sine of alpha is equal to a positive 2 square roots of 5 over 5. Y, I didn't mention, but we do know that sine is y over r. I didn't mention it when I wrote down these two, but that's why. Plug in your y, plug in your r, and you have what sine of alpha is equal to. So we have cosine of alpha and sine of alpha. For our first part here, we need cosine of alpha, sine alpha, we need cosine of beta and sine of beta. So the sine of beta is given. Let's figure out the cosine of beta. So first, where is beta located? We're told that beta is between negative pi over 2 and 0. Negative pi over 2 is down here, 0 is right here. So we are in the fourth quadrant. In the fourth quadrant, x's are positive and y's are negative. Okay? Now we're given that the sine of beta is equal to a negative 4/5. So if sine of beta is equal to negative 4/5, it's also equal to y over r. So our y is equal to negative 4, our r is equal to 5. We want to find cosine of beta, and cosine of beta is x over r. So we have to use these values and the formula x squared plus y squared equals r squared to find x. So I have x squared plus negative 4 squared equals 5 squared. So x squared plus 16 equals 25. So x squared equals 9. Take the square root of both sides. X equals plus or minus 3. But we are in the fourth quadrant. Is x positive or negative? Positive. The y is negative, the x is positive. So we want to take a positive 3. Alright, up here we said we were looking for cosine of beta, which is x over r. So that's going to be positive 3 over, well, r was 5. So now I have the sine and cosine of alpha and beta, which means I can now work out part A. Sine of alpha is 2 square roots of 5 over 5. Cosine of beta was given. It was square root of 5 over 5. No, I'm sorry. It wasn't given, was it? We just figured it out. It's 3 over 5. Plus cosine of alpha, that was given. That's the square root of 5 over 5. Times the sine of beta, which was given. That was negative 4 over 5. Alright. So that's equal to 6 square roots of 5 over 25 minus 4 square roots of 5 over 25. Yeah, they have a common denominator already. So 6 square roots of 5 minus 4 square roots of 5, that's 2 square roots of 5 over 25. That's your final answer. Alright. Now luckily for part B and part C, we've already solved for alpha and beta. So all we need to do is make sure that we write down the formula correctly. I'm going to have to get a little more space here, so I'm going to erase these two and I'll come back and write them in. Cosine of alpha plus beta is equal to cosine of alpha times cosine of beta minus sine of alpha times sine of beta. Alright. And so cosine of alpha is square root of 5 over 5. Cosine of beta is 3 over 5 minus sine of alpha is 2 square roots of 5 over 5 times sine of beta, negative 4 over 5. Alright, so that's going to be 3 square roots of 5 over 25 minus, oh, it's minus and then you have a negative, so it's going to be plus 4 times 2 square roots of 5 is 8 square roots of 5 over 25. You have a common denominator already, so you say 3 plus 8 is 11 square roots of 5 over 25. Alright, so that's the cosine of alpha plus beta. Now, the sine, part C was the sine of alpha minus beta. So the sine of alpha minus beta, that's going to be the sine of alpha times the cosine of beta minus the cosine of alpha times the sine of beta. That's going to be the same as the sum, except for the sign is going to be changed, right? So it's this formula with a negative. Well, to save some time, if you have a negative right here, you do have a negative right here. So it'd be minus a negative, so that would become plus. So you'd have 6 square roots of 5 over 25 plus 4 square roots of 5 over 25. So 6 plus 4, that would be equal to 10 square roots of 5 over 25. And then you'd want to simplify, divide those both by 5. And you'd have 2 square roots of 5 over 5. That's your final answer there. Alright, the last problem, that was part C. The last problem is part D. The tangent of, let's see what we wanted, the tangent of alpha minus beta. So write down the formula for the difference for tangent. That's going to be the tangent of alpha minus tangent of beta over 1 plus tangent of alpha times tangent of beta. Now we weren't given those answers. We weren't given the tangent of alpha or the tangent of beta, but we can figure them out by using sine and cosine. So the tangent of alpha is going to be the sine of alpha divided by the cosine of alpha. So the sine of alpha is equal to 2 square roots of 5 over 5. And the cosine of alpha is equal to square root of 5 over 5. Alright, so if I flip and multiply, like a lot of stuff's going to cancel out. Square root of 5's cancel out, the 5's cancel out, and I'm just left with 2. Kind of like that. Alright, so that's what happens whenever we solve for tangent of alpha. Now let's solve for tangent of beta. Tangent of beta is going to be the sine of beta over the cosine of beta. So the sine of beta is negative 4/5. The cosine of beta is 3/5. Flip and multiply. So you get negative 4/3. Alright, so let's see. Let's now figure out the difference for tangent. So I'm going to have tangent of alpha is 2 minus tangent of beta is negative 4/3 over 1 plus tangent of alpha times tangent of beta. Alright, so I do have minus a negative in the numerator. That does become plus. I need to say 2 plus 4/3. So 2 is 6/3, right? So 6/3 plus 4/3 is 10/3 over. Alright, that's going to be a negative right there. So that's 1 minus 8/3. So I have 10/3 over. If I change 1 into thirds, it would be 3 over 3. So 3 over 3 minus 8 over 3 is negative 5 over 3. Flip and multiply. So I'll multiply by negative 3 over 5. The 3's cancel out. And I'm left with a negative 10 over 5. And so negative 10 divided by 5 is negative 2. Final answer is negative 2. So what if we had the problem set up using like a formula and we needed to match it with the correct sum or difference formula and go backwards? Like let's say that I had the sine of 20 degrees times the cosine of 80 degrees minus the cosine of 20 degrees times the sine of 80 degrees. So what you would want to do is you'd want to figure out which formula does that match. So you want to use the formula that has sine cosine and then plus or minus cosine sine. And so that would be the formula for sine. Now look at the plus, this plus or minus that's in between the terms. For sine, if there's a minus here, then it's a difference. So this would be equal to the sine of, and remember, the first angle measures alpha, the second is beta in the formula. So this is the sine of 20 degrees minus 80 degrees, which would be the sine of negative 60 degrees. And now we can apply the even-odd property. So that would be the negative sine of 60 degrees. And then we know what the sine of 60 is. We know that that is square root of 3 over 2. So that's how we could take a problem that's already set up with a formula and go backwards and figure out what the answer would be. All right, let's do another one like that. So the cosine of 40 degrees times the cosine of 10 degrees plus the sine of 40 degrees times the sine of 10 degrees. So we see cosine, cosine, sine, sine. That tells us that it is a sum or difference for cosine. With cosine, if you have a plus here, then it's a difference. You have a minus whenever it's set up at the front. So this is going to be the cosine of 40 degrees minus 10 degrees. Alright, and 40 degrees minus 10 degrees, that's the cosine of 30 degrees. And the cosine of 30 degrees is a square root of 3 over 2. Alright, let's do one more like that. Tangent of 40 degrees minus tangent of 10 degrees over 1 plus tangent of 40 degrees times tangent of 10 degrees. So of course you can tell this is a tangent, and then if there's a minus in the top, that means it's a difference for tangent. So this is going to be the tangent of 40 degrees minus 10 degrees, which is the tangent of 30 degrees, which is what? Square root of 3 over 3.